Hi students, welcome to Susan's Learning Room. CBSE Class 10 Mathematics Chapter 2 Polynomials. CBSE Class 10 Mathematics Chapter 2 Polynomials. This is our third class. So please do watch first and second class prior to this video. Okay. Today we are learning geometrical meaning of zero of a cubic polynomial. Okay. So here we are taking a cubic polynomial. We already studied the geometrical meaning of zero in the case of a linear and quadratic polynomial. Now it's cubic polynomial. We are taking an example, that is y equal x cube minus 4x, right? And here we are substituting various values for x and to find out the corresponding values of y. First leave x equal minus 2, then y equal minus 2 the whole cube, minus 4 into minus 2 equal minus 8 plus 8 equals 0. Then x equal minus 1, y equal minus 1 the whole cube, minus 4 into minus 1 equal minus 1 plus 4 equal 3. Then x equals 0, y equals 0 cube minus 4 into 0 equals 0 minus 0 equals 0. Then x equal 1, y equal 1 cube minus 4 into 1 equal 1 minus 4 equal minus 3. Then x equal 2, y equal 2 cube minus 4 into 2 equal 8 minus 8 equal 0. So in this case, we got three cases in which y equals 0. This case and this case and this case. We are representing this x and y values in tabular form. Then we get minus 2 0, minus 1 3, 0 0, 1 minus 3 2 0. Here three cases are there in which y equals 0. And we need to, and in these three cases, there are three x values, corresponding x values are there. We need to find the corresponding x values. Here minus 2, 0, 2 are the corresponding x values. That is, when we put these values in the place of x, we got y as 0. So these are the zeros, that is minus 2, 0 and 2. So from this tabular form itself, we got the zeros. That is, whenever we replaced x by certain values, in which all values we got y as 0, that values of x are known as the zeros of this particular polynomial. Okay. Now, we are plotting it in a graph. This is a graph. Various points are marked. Minus 2, 0, minus 1, 3, 0, 0, 1, minus 3, 2, 0. And we got a graph like this. When we look at this graph, there are 3 points in which the graph meet the x coordinate, right? This point, and this point, right? Minus 2, 0 and 2. These are the 3 points in which this graph meet the x coordinate, right? Why 3 points? Because it's a cubic polynomial. In the case of a cubic polynomial, at most 3 points are intersected when we plot a graph like this. In the case of a linear polynomial, only 1 point. In the case of quadratic polynomial, 2 points, right? Okay, here we can conclude that here minus 2, 0 and 2 are the x coordinates of the only points where the graph of x cube minus 4x intersect the x-axis. Geometrical meaning of zeros of a cubic polynomial, right? Here we are studying two cases in which there is single zero and two zeros in the case of a cubic polynomial. First case, y equal x cube. We are taking the example y equal x cube. We are substituting values for x and corresponding values of y is being not out. Okay. When x equal minus 2, y equal minus 2 the whole cube equal minus 8. When x equal minus 1, y equal minus 1 the whole cube equal minus 1. When x equal 0, y equal 0 cube equal 0. When x equal 1, y equal 1 cube equal 1. When x equal 2, y equal 2 cube equal 8. Now, we are tabulating it in a tabular column corresponding x and y values. Minus 2, minus 8, minus 1, 0, 0, 1, 1, 2, 8. So here, y becomes 0. When y becomes 0, this point. Here y becomes 0 and the corresponding value of x when y becomes 0 equals 0. So we got the zeros, only one zero, that is 0, right? This one. Y becomes 0 in only one case. Okay. Now we are plotting it in a graph. -2, -8, -1, 1, 0, 0, 1, 1, 2, 8. In this graph, we can see only at one point this graph intersect the x coordinate because it has only 1, 0. Now, we can move to the other case in which there are two zeros in the case of a cubic polynomial. Here we are taking the example y equal x cube minus x square. Now we are substituting various values for x and corresponding values of y is no doubt. When x equal -2, y equal -2 the whole cube minus -8 the whole square equal -8 minus 4 equal -12. When x equal -1, y equal -1 the whole cube minus -1 the whole square equal -1 minus 1 equal -2. When x equals 0, y equals 0 cube minus 0 square equals 0 minus 0 equals 0. When x equal 1, y equal 1 cube minus 1 square equal 1 minus 1 equals 0. When x equal 2, y equal 2 cube minus 2 square equal 8 minus 4 equal 4. Now we are tabulating in a tabular column. -2, -12, -1, -2, 0, 0, 1, 0, 2, 4. Here there are two cases in which y becomes 0 and the corresponding values of x 0 and 1. So we got zeros as 0 and 1. Right? Now we are plotting in a graph. -2, -12, -1, -2, 0, 0, 1, 0, 2, 4. This is the graph. Here there are 2 points in which this graph intersect the x coordinate because it has 2 zeros. So we have studied at most 3 zero case, right? In which this graph intersect 3 points, and here we studied 2 zeros in which graph intersect 2 points, and the last one the graph intersect at only 1 point. We have studied 3 cases, that is at most 3 zeros can be plotted in the case of a cubic polynomial. So we finished the geometrical meaning of the polynomial in the case of linear, quadratic and cubic. Now we can move on to the examples and the exercises. Thank you.